go. Okay, so lesson 10, domain and range, part 1. 11 is part 2, but like I said, we are combining them all into one. So here we go. 10.1, it says earlier you saw a situation where the total number of times a dog has barked was a function of time. So quick little review, we have this little phrase, was a function of, or we always saw is a function of, and that's when we see that little phrase, it tells us a variable that's in front of it and a variable that's after it. Okay, that tells us the input and the output. Do y'all remember that? Okay, so which one comes first when it's written like this? Remember, this means depends on. Do what? The first one is the what? The first one is the output, the y value. Because the y value depends on the x value. So the input would be time. Okay, so the number of barks is dependent on how much time has passed. Okay, another quick little review was function notation. So the most basic function notation looks like this, f of x. What does this letter in function notation tell us? Just that letter. That's the name of the function, okay? So it can be any letter, but that just tells you the name of it. Okay, then we have the number or variable inside of the parentheses, and that tells us the input. And then all of it is set equal to the output. Okay, so that's function notation for you. Okay, so in this case, our input is going to be time, and what all it's set equal to is going to be the total number of barks. Okay, so then it says the time in seconds after its owner tied its leash to a post and left. Less than 3 minutes after he left, underline less than 3 minutes. Okay, because that has to do with the amount of time that takes place in the situation. The owner returned, untied the leash, and walked away with the dog. Okay, so number 1 says, could each value be an input of the function? Underline input. All right, so when we're talking about the input in this situation, what are we talking about? What's the input of this situation? Time. Okay, so all of these values down here represent time in seconds. Okay, and we want to see if they could be a value for this situation. So, first one, 15 seconds. Could 15 seconds have taken place in this situation that we just read through? Could 15 seconds have passed? Okay, I see a yes. Why do we know for sure that it is a yes?
Because it says less than 3 minutes.
Less than 3 minutes. Does 15 seconds fall within that time? Yes. Okay, so that would be a reasonable input that would work for this situation. So you can just put yes. All right, what about 84 and a half seconds? Could that be a reasonable amount of time that passed? Yes, 84 and a half seconds also falls in less than 3 minutes. And then finally, 300 seconds. Would that one? No, 300 seconds would be 5 minutes. Okay, so it would not be one. Now, when we are talking about all of the possible inputs of a function, we are talking about the domain. Okay, so we know what inputs are. Those are all of our x values. But when we take all the x values and put them together, all of them, that's considered the domain of the function. So you're just grouping all your x values together and you call it your domain. All right, next. Number 2, bless you, it says, could each value be an output of the function? Underline output. What is my output talking about for this situation? What did we say?
Total number times dog.
Okay, the number of barks. I'm just going to kind of shorten it. Okay, so our output's talking about the number of barks. So we're going to see if these are reasonable amount of barks that could have happened within this time. Now, we don't have any constraints like we did with time where it says less than 3 minutes. So we just have to think, is that possible for this situation? Okay, could the dog have barked 15 times?
Yes.
Yeah, that seems reasonable. All right, could the dog have barked 84.5 times? You can't bark half a time. No. So we know it can be a whole number that's less than the 3 minutes, but it can't be a fraction or a decimal. So no, can't bark half a time because it does say to explain. All right, and could it have barked 300 times in the 3 minutes? So 3 minutes is 180 seconds. So if it barked 300 times, that would mean it would have to bark more than 1 time per second consistently.
Just barking the whole time.
Yeah. So I'm gonna say probably not.
I'm gonna say question mark.
I'll say yes.
Maybe.
All right. So when we are talking about all of the possible outputs of a function, so all of the y values that would work with this function, we're talking about the range. Okay, so domain is all of your x values. The range is all of your y values. Okay, not confusing, but it is confusing if you don't know the difference. Focus. It is confusing if you don't know the difference or you don't know what you're looking for. Okay, now before we move on, I'm a very visual person. So we're going to draw a picture of kind of what this looks like. So down here at the bottom of your paper, right here where it says number 2, the tennis camp question, y'all see it? Okay, right under this paragraph right here where it says like collects is a function of the blah, blah, blah. We're going to draw a little box right underneath that. We don't need all that space. So we're going to draw a picture. Okay, so that's how big my box is. All right, and we are going to draw a picture of what the domain and the range looks like. Okay, so I'm going to start off with drawing a little coordinate plane. Okay, I have my x-axis and I have my y-axis. Now I'm going to draw me a little function here. Okay, it looks like that. Doesn't have to be perfect. Okay, so whenever we are talking about the domain, we're talking about the x values, right? Okay, what is the x-axis? How does it move? Left to right. Okay, so when you're measuring the domain, you're measuring your function from left to right. Okay, so we just see where it starts the furthest to the left. So I'm going to put a little line there, and I'm going to see where it goes all the way to the right. Draw a line there. So all of that space in between, from the beginning of my function on the left to the end of my function on the right, is considered its domain. Okay, so you read the domain left to right, not right to left. You read it like you're reading a book. Like an English book. I gotcha. Okay, so the range is all of your y values. How does the y-axis move? Up and down, okay? So you start the lowest point of your function. All right, and then you go to the highest point of your function. Okay, so yours may look a little different than mine, but about right there. Okay, so from the lowest point to the highest point of your function, that is considered your range. Okay, and when you're reading range, you read it down to up. I know that seems confusing, but you always have to start with the lowest point and go to the highest point. Okay, if it makes it more sense to you to write lowest to highest instead of down to up, you do what you need to do. Down to up, bottom to top. That sounds better, yeah. Down to up, lowest to highest, bottom to top, whatever you need to say. Now, when I ask you questions here as a little review, like the domain stands for the X values, range stands for the Y, don't just guess one of the two because there's a 50-50 chance. Go back and look at your notes so that we can like actually learn it, okay? Now 10.2. All right, it says I'm going to give you a bunch of cards, but we're not going to do that. We're just going to make up our own. Number one. The area of a square, underline area of a square. That's important because there's certain things we know about a square. What do we know about a square?
4 sides.
4 sides,
Equal sides.
and they're all the same length. Okay. So when we're finding the area, what do we do to the side lengths to find the area?
Measure. Multiply.
How do you find the area?
Length times width.
Length times width, okay? So if the side lengths are the same, we can just square them because it's the same number. Okay, so they gave us this little function here. Okay, where S right here in my input stands for the side length. Okay, so we're going to take the side length and square it in order to get the area. Okay, so I'm going to just draw a little square here. You don't have to if you don't want to. Okay, but that's the side length. That's the side length. We're going to square it in order to get the area. Now, so we're trying to measure out an area or try to find the area of a square. What are some possible side lengths that this square could have? Raise your hand. What are possible side lengths, Kai? 4. Perfect. Okay. If that side length was 4, what would the area be? 16. Good. Okay. What is another side length, Ava? 5. Look. 6. Kobe. I'm gonna spice it up. What's
98.
32.
okay? 32. Okay, real quick, Kobe, going back to yours. Okay, so we've got a lot of whole numbers here, but sometimes when we're like building or measuring and doing that kind of stuff, what kind of numbers do we get?
Fractions.
Fractions and decimals. So Luke said 9.5, 2.8.
3.4.
3.4. Okay, so we could keep going on and on and on forever. Now we're going to go to impossible inputs. What could the side length of the square not be ever?
100,000.
It could be 100,000.
Oh.
0.
It could not be 0.
I thought you were talking about that square.
Oh, no. I get what you're saying. It could also not be negative. I think I heard Connor say that too. Okay, so give me a number. -3. Okay. What about -3.5? No, still not. Okay. So when we're talking about all the possible inputs,
It's not possible to be 102.
all right, when we're talking about all the possible inputs here, when we're talking about inputs, those are our X values. So what did we just create? our domain. Okay, when we're talking about all of the possible inputs for a function, you're creating the domain. Now, we said we could go on forever and ever and ever with these inputs, but they could never be what? Negative or zero. So it could be any number that is positive, which we could just say if our x value is greater than 0. Okay, so our possible inputs could be any x value that is greater than 0. Do y'all agree? Okay. What?
So, a negative times a negative was equal 0. It's the same.
A negative times a negative, no. It would still be whatever you multiply by, be positive. But a length of something could not be negative. What?
Is negative 0 a thing?
No.
Because I've seen it.
No, it's.
I'm drawing.
Okay, next. So for this one, if we're gonna look at this graph here in just a second, and you're gonna see kind of what this looks like in a graph. Like when we graph this function right here, you're gonna see how this is true. Next. Okay, we're looking at a tennis camp. It charges $40 per student, okay? So if we were going, Ava would have to pay 40, Lainey would have to pay 40, and so on, okay? The camp, let's just focus on what it says. It says the camp runs only if at least, underline, at least 5 students sign up. Okay, so it can only, we can't just take like, I could, as a coach, I couldn't just take 2 players. I would have to take 5.
Who would be the other 3 that?
All right, and it limits enrollment to 16 campers a day. So I have to take 5, but I cannot take more than 16. So underline limits the enrollment to 16 campers a day. All right, now the amount of revenue in dollars that the tennis camp collects is a function of the number of students. So there's that little phrase, is a function of. Now this is important because here in a second, it's gonna ask us about the inputs and outputs, but it doesn't tell us which one is my input or my output. We have to figure that out. So whenever we see this phrase, we know that the variable before it and the variable after it are the input and the output, but which one is which? The one that comes before it is always the output, our y value. Okay, so when we're talking about the revenue, we're talking about the output. Okay, so that makes the number of students my input,
So you're
my x. All right, write that down. Okay, so now we have this function here where it says that we can figure out the revenue if we take $40 per camper and multiply it by each student that goes, right? Okay, so 40 times 1 student would be 40, 40 times 2 students would be 80, and so on. All right, now it's asking us for possible inputs again. What is my input talking about? The x, the domain, and it's specifically the
student.
number of students. Okay, so how many students could I actually take to this camp? Give me one possible input, Ava. 7. 16. Kai? 12.
1, no,
5. Jamarius? 8. 6.
15,
15.
14.
Any positive numbers that
Any positive numbers that aren't
aren't fractions or decimals?
fractions or decimals? Good. Okay, now we'll get to that in just a second. Now let's look at impossible inputs. Which numbers could not go for this particular function, Ava?
0.
0.
1.
1. Kobe. One-
Through anything negative, which, I mean, it'd be pretty weird. if you took negative.
It would be 4-3.
It'd be weird if you took a
negative,
bunch full
if
of
you
nobody.
take kids away from the camp, and that's kind of illegal.
Negative 22.
Yeah, we can have negative numbers. Kai,
2.5.
2.5. Okay, good. I like that one because I know that's an impossible, but it's wrong for two reasons. One reason is why?
Taking half a student.
Can't have half of a student.
If you really want to, you probably could.
Split it down the middle.
You can't have 2 kids.
Okay, and we can also not take less than 5. Okay, so that one was a good one. I like it because it was wrong for two reasons. Now, good. So those are, once again, when we're talking about all of the possible inputs of that function, we are talking about the domain. Now, were those the only ones we could have had
No.
that we listed? Kobe said something.
Anything positive that is before 16 and after 5.
Yeah,
Good.
anything between 5 and 15.
Good. So if our X value was greater than or equal to 5, but also
Less than 16.
if our X was less than or equal to 16. Okay, that would be our domain. All right, we also have one other specification that we have to make about it. Since we're talking about people, what kind of numbers do they have to be? Whole numbers.
I mean, did you see what happened Friday? Did you go to Midget Wrestling?
Those are still whole people.
Oh, yeah, but Midget Wrestling was really fun. I mean,
I saw Zach's story.
dude, Jackson Lynch was crazy. Funny, because Midget Wrestling.
All right, moving on. Okay, so now we're gonna look at the graphs of these same two functions that we just looked at, the area of the square and the tennis camp. Okay, so, and then after this one, we're gonna take a quick break. It says, in an earlier activity, you saw a function representing the area of a square. Its name is A. And another representing the revenue of a tennis camp, R. Refer to the descriptions of those functions to answer these questions. Okay, they should still be pretty fresh on our minds. It says, here's a graph that represents function A, which once again is this guy. Okay, so here's its graph. All right, now, if you remember kind of what we said earlier about this function, when we're talking about the side link, we said that they would always have to be,
Equal.
they would always have to,
Whole numbers.
they would have to, nope,
Greater than.
they had to be greater than 0. Look at this graph. Are all these positive numbers that we're
No.
working with?
It started off as 0.
Yeah.
It's,
Actually.
it did, but
More.
I'll explain what this guy is here in a minute. But yes, they're all positive, okay? So, part A, it says name 3 possible input-output pairs of this function. Input-output pairs is just an X and a Y value from the graph, okay? So if it's an input-output pair for this function, that means that it would fall on the line. So I'm gonna do one with you and then we're all gonna come up with 3 more. Okay, so if my input was 1, that means the side length was 1. What would the area of my square have to be? Think about it. It would be 1. Okay, because 1 squared would be 1. Look, let's look on the graph. Yeah, that looks about right. Okay, so it's kind of hard to see it on the graph, focus. It's kind of hard to see it on the graph, so we also have to know kind of how we're getting them. All right, what is another input-output pair that would be true for this function, Ava?
5 and 25.
5 and 25. Good. Okay, let me graph it real quick. All right, Luke, give me one more.
6 and 36.
6 and 36. Last one, Kobe. 2 and not 8.
9.
No,
That's a 4.
Yes.
I was thought that was
Whoa.
Okay, so we came up with 4, but y'all came up with 3 on your own. Now, real quick, this is my own thing I'm adding to it because you're going to have a question like this here in a minute. We're going to talk about the domain and the range of these input-output pairs, okay? So write this out like this.
How was your screen break?
That's
Okay,
great.
we're almost at.
Okay, so when we are, when you're given these input-output pairs and it asks you about the domain, all it wants you to do is list all of your X values, okay? So when you do that though, you have to put it in this little funky bracket. Don't ask me why, that's, just do your best. It doesn't have to be perfect. Just make a squiggly parentheses.
It
if
looks
you-
like a nose and a mouth and a big chin.
Keep going.
Okay, now, when you're listing all of the X values in your domain, you have to put them in numerical order. I told you domain goes from left to right, correct? Okay, in this case, they're all positive, so it's kind of easy, but if we did have negative values, you would have to start with your negatives and then go to your positives, right? Okay, so if we're starting from our lowest number, what is our lowest X value?
1.
1, just by the ones we listed, I'm sorry. Okay, so 1, and then what? 2, and then 5 and 6. Okay, and then you just, I can't do these brackets there. Okay, so that is how you represent a domain when it asks you to list it out. Now, range is a little bit different. If it did not ask me for the domain to begin with and it just asked me for the range, I would do the exact same thing. But when it asks me to do them together, I have to match up the range with its correct Y value. So for example, I started with 1, so I have to put that Y value first. So its Y value would also be 1. Okay, then I did 2, so it would be 4, then 25, then 36. Now this one just happened to also be in numerical order, but it won't always be like that, and you'll see that later when you practice it. Okay, so if it just asks you for the domain, put it in numerical order. If it just asks you for the range, put it in numerical order. If it asks you for both, you have to do the domain in numerical order and then match up the range. You'll practice it a lot here in a minute, so you'll be able to practice that.
That's my favorite part about that.
Okay, so that's the domain and range again. Now, it says earlier we described the set of all possible input values. Underline all possible input values. What's that called? All the inputs, domain.
Oh,
Okay, and we said it was any number greater than or equal to 0, okay? AKA, it's
Range.
positive. No. When we're talking about it being greater than or equal to 0, that's what this is showing. Our function is continually getting greater than 0. How would you describe the set of all possible output values? Underline the set of all possible output values. Okay, so if all the possible input values is our domain, what is the possible output values called?
Range.
The range. Okay, those are our Y values. All right, so that means we go from the bottom of our function to the top of our function.
Down to up.
All right, down to up. So what's the lowest point of our function here on our graph?
1.
0.
Is
All
that
right.
even possible?
And then,
Or square?
and what is the highest point on our graph? It goes to 50, but with what we know about
Go higher.
area, it could continue going exponentially higher, right? It goes on forever and ever. Okay, so if we start at 0, it can be any number that is greater than 0. So we could just say Y is greater than 0.
Alligator eats water.
Mary's out here.
Okay, so all of our Y values, any of our output values can just be any number that's greater than 0. All right, now, number 2, Number 2 has 3 parts, but they're quick, and then we'll take a break. Okay? It says function R, remember this is the tennis camp. Okay, it's defined by this function, Rn equals 40n, where n is the number of campers. Okay, we remember that. Now, earlier we talked about possible input values when we were talking about the students. Now it wants to know possible output values. So if we're talking about the output or the Y values, we're talking about the range
Down to up.
down to up, correct. Okay, so looking back at the tennis problem, what is the output talking about?
Amount of revenue.
The amount of revenue. So how much money the camp is making, correct? From your team. Okay, so the first one asks us, is 20 a possible amount of money that the camp could make from just our team?
No.
Okay, so let's write this down. We have $20. We said no. Why can 20 not be a possible output for this? Because it's $40 for one student, and how many students do we have to have?
5.
5. Okay, so for one, this would be considered half of a student's cost. And then, but we can't even just take one student. We have to take 5. Okay, so no. Because one student costs $40. And we have to take at least 5 students. Okay, something along those lines, so that when you look back at it later, if you have to, you can know what we're talking about.
Nope.
Next,
No.
same question. It wants to know if 100 is a possible amount of revenue that the camp could make.
No.
Man, that's too low.
No.
That would be 2.5 students, right? Because one student's 40, 2 students is 80, 3 would be 120, so that would be half. So once again,
Because a half
no.
student is not possible.
So we can say we can't take 2.5
I mean, if
students.
you cut his legs off.
Nope, that'd still be a whole person.
Oh, what
It
is
would still be a whole person.
A whole?
Yes.
And should I?
He'd be in half.
Like girl who like lost her arm, but like got the prosthetic and like one of the best volleyball players.
Mm-mm.
Oh, like the track runner for Arkansas?
Well, she
Oh, yeah.
lost her arm like a year ago yesterday.
Really?
It's like a really good.
Trying to look her up. All right, 2 more questions and then we'll take a break. It says here are 2 graphs that relate the number of students and camp revenue in dollars. Which graph could represent the tennis camp function we've looked at? Explain why the other one could not represent the function. Okay, so we've got graph 1 and we've got graph 2 here. Okay, I'm gonna give you about 30 seconds. I want you to circle or put a check mark beside the correct graph. Don't say it out loud. We'll talk about it in just a second. I'm gonna give you 30 seconds, go. Kids at home, I want you to send me your answer in the chat.
Put a square.
Just send me graph 1 or graph 2. Okay, don't say it out loud. I want everyone to have to think about it. If you are finished, give me a thumbs up. Good, Caitlin. Gracie, look at it one more time.
Andre, so you guys can do it. I believe in you.
Good, Emily. All right, so which graph is it? Raise your hand, Kai.
Far right.
The far right, this
Oh,
graph
right.
2.
The only right. All right, and left. You say far right.
I did.
All right, so this is the correct graph. So let's talk about why this one is not correct, okay? Why is this graph not correct? Lenny, give me one reason.
Because you can't have under 5 students.
Oh, yeah.
Good job, Lainey. Good
You know,
job.
All right, we can't have under 5 students, so our graph should have stopped right there, okay? What's another reason that it is incorrect? Like,
Because of the money. Because,
Oh, I know, I got it.
I do too. Explain my answer.
Kobe,
Alright, so it's, cause it's a straight line, so it's basically saying that there could be half decimals on people.
good. Okay, so Kobe said that it's a continuous line. So unlike this one where it is just the dots, if it's a continuous line, it's taking into account all of the fractions and decimals in between these whole numbers. And we already discussed earlier, these have to be whole numbers. So it can only be 5, it can only be 6, only 7, only 8. Okay, so it can't be continuous. And there's one more reason, Ava.
Because you have to have, less than 16.
We have to have less than 16, okay? So it should have stopped right there. Okay, so those are the reasons why that one was incorrect. All right, now, last question. It says, describe the set of all possible outputs. Circle all, and then underline possible output values. Now, when we're talking about the output, we're talking about the y, which is the range. Once again, okay, so we want to see from the lowest point of my function to the
200.
highest point of my function. Okay, so I just drew that little line up there on my function. That's the range. All right, now it wants us to describe the entire set. Okay, so just like earlier, we have to put that funky little bracket. All right, what is the lowest point on my function? 200. Okay, and it wants us to describe all of them. How is it increasing?
250.
Nope,
40,
by 40, so it would be
40,
240. All right, then 280, then 20. Okay, y'all get those down. 200, 240, 280, 320, and 360.
Did you do that in your head?
Mm-hmm.
This camp makes bang for a tennis game.
Okay, so then we have 400,
400.
440,
Gosh.
480. We have 520,
Oh my goodness.
Number
we have to keep
640.
going forever.
560.
No.
Nope, that
Oh,
caps
it only
out.
goes to 16. That's
Okay.
a lot of numbers.
And then we have 600, and then it finally stops where?
640.
640 when we have 16 people go. All right, so no matter what, if we show up at this camp, how much, with the least amount of people, how much money could this tennis camp make? 200 with the least amount, and how much total could it make from our team? 640. Good. All right, so we're gonna take a quick break and then we're gonna come back for the,
Hold on a second.
all right, 10.4, consider this function. We have f of x equals 6 divided by x minus 2, okay? So that's the function we are going to be working with today. So it says to find the set of possible input and output values of the function, Claire created a table and evaluated f at some values of x. Along the way, she ran into some trouble. Underline, she ran into some trouble.
Okay.
Okay, we're gonna deal with that today. Now, number one, this is throwback to a skill we've done before. This first, number one has nothing to do with domain and range just yet. Okay, this is a throwback question. It says find f of x for each x value Claire listed. Describe what Claire's trouble might be. So we're gonna use this function. We have an equation, we have variables, what do we do?
Plug 'em in.
We plug them in. So I'm gonna do the first one with you. So we have f of x equals 6 divided by x minus 2, right?
Yes.
Okay, so that's my function, and it tells me right here that x equals -10. So what am I gonna do with this -10?
Plug it in for X.
Plug it in for x. So I have f of -10 equals 6 divided by x minus, or I'm sorry, -10 minus 2. Okay, so let's simplify this. So we have, let me come up here. So we have f of -10 equals, can I simplify this numerator? No, it just says 6 for now. All right, what's -10 minus 2? -12. All right, now, does this simplify over here?
No.
No, it just stays f of -10. Okay, what's 6 divided by -12? Use your calculator.
Negative 0.5.
-0.5, -1/2, whichever one you got. Okay, so when our x is -10, our f of x or our y value is what? -1/2. Or -0.5, whichever one you want to draw. All right, I want you to do the rest of that table,
Okay.
and then we will talk about it. I'm going to give you about a minute or two.
Do we do it on paper?
You don't have to do it on paper. You can use your calculators. I just wanted to show you, remind you how we did it. Okay, I'm going to give you about a minute and a half, and then we'll talk about it. Ready? Go.
Can you move your sheet over a little? Thanks. I just promised to. Unless you did one. You know your teacher.
I went fishing Sunday,
Uh-huh.
a pond behind my house, and I caught me a bass. I was proud of him, his name's Frankie.
Did you throw him back?
He did now.
Cacti.
I was like, I got a picture, and then went to go take it off the hook, and I was like, and I kissed it. My grandpa was like talking to some dude. I was like, okay.
I don't know why you take a picture of me.
Got about 20 seconds left to get it done.
25 seconds.
25 seconds. That's like,
I just got that.
Of course, 100. It is. But that's not.
Keep working. I'm gonna get me a calculator and.
Don't grab one with little batteries.
I need to go through and get all the batteries.
You should make me hold you that. I mean, just hold it.
Duracell or Energizer?
Did you know most batteries
It's the
are,
ones the school bought.
did you know like most batteries are upgraded to save?
All right, here we go. When I have 0 as my input, what is my output? -3. Because 0 minus 2 would be -2. 6 divided by -2 would be -3. All right, if it's 1/2, what is my output?
-4.
Let's look. I'm gonna do my denominator first.
That's -1.5.
Just 1 second. All right, so we have 1/2 minus 2. Okay, so I have 6 divided by -1.5, which is
-4.
-4. All right, next I have 2. What's 2 minus 2?
0.
What's 6 divided by 0?
0.
You can't do that. Look, 6 divided by 0. You error. You can't divide by 0. So we're just going to put a little X there. And we'll talk about it in just a second. All right, now 8. When 8 is
1.
my X, I get 1 as my output.
Wait, can we not divide by zero because there's something they don't want us to know?
No, y'all haven't learned what it's called, but this is the problem that she ran into. Okay, so we're gonna talk about this in just a second, but remember, along the way, she ran into some trouble, so I'm sure it might have something to do with
The zero.
that. Okay, now let's look at it. Number 2. It says use graphing technology to graph function f. Underline graphing technology, okay? We're gonna use Desmos. Y'all don't have to get it out, y'all just watch me. All right, now we're just gonna make some observations. So don't zone out on me. Let me pull it up on my screen.
This is a guess. I'm assuming it's not. Really-
Okay, so let's graph it and see what we notice about this graph. Okay, 6 divided by x minus 2. All right, what do you notice about my function? Now it's the red part of it. What do y'all notice about it?
It,
Kobe, look up here. What do we notice about the function?
it goes crazily.
It's not a straight line. It's not even one curved line. What is it? It's mirrored. It's split in 2. Okay. Where do y'all notice it's split in 2 at?
Right below zero.
Wait, did I do this right? Yeah. Okay, so it's count by 5s here. Where's it kind of veering off here?
Negative
About
3.
Around 2. That's interesting. Isn't that where we kind of ran into some problems? Yeah, it is. So going back to our paper, what do you notice about the graph? We notice that the graph is split up. All right, and it was split at x equals 2. All right, and I'm just gonna draw a little rough sketch of what my graph looked like, just so I can refer back to it. Kind of looks like this. Wait, let me look again. I don't remember where it's right above it. Okay.
Starting to go crazy yet.
Okay. So the graph is split up and it was split at x equals 2. Now it says use a calculator to compute the value you and Claire had trouble computing. What do you notice about the computation? What happened earlier when we put that, when we put 2 into our function? What did our calculator say? Error, okay? So let's draw that out. So we had f of 2 equals 6 divided by 2 minus 2. Okay, so let's simplify that. So we got f of 2 equals 6 divided by 0. Okay, so right here we got an error.
Yeah, can't divide by zero.
Can't
You need to quit or go to.
divide by 0.
Sorry.
All right, so I want y'all to see what happens while we got an error at that point. I want y'all to look up here at my graph. People at home, can y'all see my screen still?
Just one of y'all just say yes.
Yes, ma'am.
Okay, good.
It worked.
All right, now let's look back at my, y'all can't see that. So I'm looking at my graph. I'm gonna put f of 2. X equals 2. All right, so it just created this green line. Now, so that was where, when our x value is 2, what do you notice about this green line in our function?
It just keeps going, getting closer to that red line.
It does, it is getting closer, but that line will never, ever
Cut.
touch the function, okay?
You know what that means?
There is a word for that. You don't have to know it right now. But the reason I know it's never gonna touch it, listen, the reason I know it's never gonna touch that line is because this is, it's called an asymptote, is the vocabulary word. It's a line that approaches a function, but it will never ever cross it, okay? So the reason we kept getting an error when we plugged in 2 is because the x value of 2 doesn't land on our function. And we learned earlier in the year, if something does not land on our line, what is it? It's not a solution, okay? So that's why we kept getting an error message, because it's not a solution. Yes.
Am I allowed to say without clicking this? It kinda sounds like a naughty word.
It does sound like a naughty word, but you are allowed to say it. It's not actually a naughty word. Asymptote. All right. Shh, focus. I said it. It's asymptote. That's the word. All right, now it says, how would you describe the domain of the function? Underline domain. Okay, we are going to be describing all of our x values. Okay, so we know our x values. How does our x-axis move?
Do we got to do the little?
Left to right.
we gotta
Okay,
do that.
you'll see. All right, so let's look at our graph. Let's see how far it goes to the left. Do we see like a starting point all the way to the left?
No.
No, it goes on and on and on forever to the left, and it goes on and on and on forever to the right. What is the only number that it doesn't ever go to? 2. Okay, so when we're talking about the domain of this, it's going to be all real numbers except what? 2. Okay, so all of our x values can be any number ever except 2, because that is where my graph is split up there. Huh?
He showed all those cars and that was his fingers.
Oh. All right, now let's do lesson summary focus, because you are going to have to practice this now. All right, lesson summary, it's quick. The domain of a function is the set of all possible input values. I feel like I've pounded that into y'all's heads now, okay? Domain is all of the input values. Those are our x values. Okay? Depending on the situation represented, a function may take all numbers as its input or only a limited set of numbers. Okay? So we've looked at both in this lesson. Okay, turn the page. Next, down here where it talks about the range, after that second bullet point, the range of a function is the set of all possible output values. Okay, so range is all possible output values, or the y values. Okay, so that is not a hard concept, but it's easy to forget. Okay, which one is domain, which one is range? So we're going to practice it. Now, again, this is us combining 2 lessons into one, and this is also your homework. So use this time with me in here to help you. We're not getting up out of our seats, walking around, messing around. You're working on this. So I'm going to show you how to do some of these. Y'all just pay attention. Don't get on your Chromebooks just yet. Okay, so when you get here, you're going to sign in. You're going to go to Learning, Recommendations, and then you're going to go to where it has your star. So the first one you're going to do is called Domain and Range of Relations. Okay, you're going to click on it, and it looks like this. Okay, so this is the first one. So pay attention to me so that when you get to yours, and you're working in your group, y'all know what you're doing. So it says, what is the domain? All right, domain. What kind of values, X or Y? X, okay? So they went ahead and gave me my input output pairs. I just have to write it, and look, they already put the brackets for me. But I know that I have to go from smallest to largest, from left to right on a number line. So what is my smallest X value? Negative 18. I have to put a comma because look, it showed me that right here. I have to put a comma. Then it would be 16, comma, and 20.
Oh, wait,
Your
you don't
brackets
know.
did not look anything like that. They did so much better than you.
Hey, take it back.
I'm
All right,
sorry.
next, here's a really easy way to do it when it gives you the graph, okay? So we have the range. Now, when we're talking about range, what values are we talking about? The Y values, okay? So how does the Y axis go?
-3.
How does the Y axis go? Up and down, but we know we start down, okay? So I'm gonna look at my lowest point. It's right here. What's the Y value? -3. All right, then I go to the next one. What is its Y value? -1. Okay, then I go to the next value. Okay, I have 2. What's the Y value? 5. You only have to write it once. You don't have to do 5, 5.
What if you wrote both fives?
Let's see. It still counts it. Okay. But you don't have to. It'll count it correct if you don't. All right, same thing here. It gave you it. Now let's see. Next level, it just gives you more. Next level. Okay, this one gives you both. This is what I was talking about earlier. Okay, if it wants the domain and the range. So let's look. I skipped levels. No, I can. Okay, so domain. What is my smallest domain?
-15.
-15. What is my smallest? Next one. -4. Then what?
10. That you put it 3.
Okay, then what? 10, then 19. Okay, so I put my domain in order. For the range, I have to match my Y values with its correct X value. So what was the Y value when X was -15? 20, then 16, then 17, then 12.
You notice those are just all in order?
Huh?
They were just all.
Yeah, those were. Okay, same when you get to this domain. All right, there is one more that you'll do. That one's not too bad. I think you'll do fine with it. Just don't rush. Okay, now this one it seems more difficult, but it's really not, okay? It says, what is the domain? All right, so look, it gives me one of those funky looking graphs, right? Okay, domain is left to right. How far does it go to the left?
-2.
It does, but it has an arrow, so it's going on and on forever to the left, right? And then it has an arrow on the right. It's going on and on and on forever to the right. So this would be all numbers. Goes it forever in one direction, forever in the other. It doesn't stop. All right. Range, same thing, but this one doesn't go on and on forever in both directions. What's the lowest bottom point for the range? 0, and then it goes up. So it's any number that is 0 up, Y is greater than 0.
Yeah.
Shirley, can you write like greater than and less than on the board?
Mhm.
And
Yes.
then write it beside.
Yes. All right, so that is what you are doing. You can work in groups. You have 25 minutes left of class. This is homework time. You can get it finished in class today if you try.
What do we have to get our smart here?
You have to get to the challenge section, okay? You don't have to get a 100, but you have to get to the 90, okay? Because they go pretty quick.
Isn't it your first, last, and then your lunch number?
Yeah, but whenever you type it in, hit the little remember me box this
I
time.
did, and it never said.
Yeah, same. Yeah, it didn't do it any.
I forgot to
All right, here we go. Like, Ty, get your Chromebooks out. Let's go. All right, Colby, yours is just Colby Montgomery. Okay. Does anybody else need their login? Anybody else need their login?
Wait, what's the main range of relations? Okay, got it. Seriously?
What?
Don't look at this file, I don't think it's paid. 'cause it's not.
Hold on. Let me finish-
I need my login.
All right, Caitlin, it's right there on my screen.
let me finish this one.
Can you see it?
Eating just like unsweetened.
Okay.
Yes, ma'am.
Okay.
Like eating her.
Yeah.
Negative 16.
Talking to grown men.
Yeah, you told me.
I did.
I made it look